In this video I'll be walking through the VR Interaction base asset. This asset and everything you see in this video is available for free in the description down below. First we're going to be looking at the Steam Player and Oculus Player prefabs and seeing how they're set up. Then we're going to build one from scratch to demonstrate how it's done, and we're going to show that working in the scene. Then we're going to look at the items that we've got in the example scene and go through the steps for how to build them from scratch as well. Let's first look at the Oculus native player. To get this player you need to first download the Oculus integration asset from the asset store or from the Oculus website. A link to that will be in the description as well. Once you have your Oculus avatar, the main scripts go on the controllers. And the main scripts for the controllers are the VR Interactor and the VR Input script. I've added an additional script here called the Force Grab Toggle that will allow you to grab objects from a distance while you're holding down one of the keys. The VR Input script goes through each key and assigns it an action. The action can be configured on this pop-out, and the actions can be edited by opening the Edit Actions foldout. And you can add your own custom string right here. For instance, I could add pickup and click Add Action. Now it's on my list. Now if I expand this, the option becomes available, so I could assign the thumbstick up to my new thing. This can be any string, and I will show you later where this shows up and why it's important. You can also remove actions by clicking the X. The VR Interactor script adds onto the behavior of VR Input and allows you to actually pick up items. The VR Input script doesn't require the interactor, but the interactor does require input. For instance, for the Arc Teleporter script, the teleporter doesn't require the interactor, it just requires the input. So the VR Interactor by default, just as this help box says, can take pickup, drop, and action as base commands, and each command will be sent to either the hover item or the held item when clicked. And I'll show you in a bit how that's being sent. Both of these scripts are on each controller, and the only difference is they reference different child objects. You can see the Force Grab direction and distance set here. The Force Grab Toggle script will actually change it from being 5 to being 0, and then when you hold down the action name here, it will toggle the distance. This allows you to grab something from a distance by holding down a custom item. For instance, this action name could be the action button, which is also used to pick things up. So if you change this to action instead of pick up and drop, then you would hold down the trigger in this setup to hover over a distant item and the grip button to actually pick it up. The current setup, the grip button will make it hover and the trigger will actually pick it up. For the Steam VR setup, it's pretty much the same. It's using the Steam VR camera rig, and on each controller, just as before, it has the 3 same scripts. You notice here on the Steam VR version, because Steam VR supports both Vive and Oculus, you can actually display the Oculus keys or the Vive keys, depending on which device you're on. And there's a little toggle here to mirror controls. If you untick this, they'll be separate, and you can actually make a different control scheme for Oculus than you have for Vive. Both of these are on Steam VR. Okay, so sometimes when you import just Steam VR or just Oculus integration, these prefabs that are found in the project, in the prefabs folder, they have missing scripts. Even so you've imported Steam VR, sometimes this will show up as missing. I'm not sure exactly why that happens. Sometimes it just messes up. If you actually import both Oculus and Steam VR, then it somehow finds everything. Even so, technically this was the Steam prefab and it shouldn't have been missing in the first place. But sometimes that happens, so sometimes you'll have to build the prefab from scratch. So if it is missing in your missing scripts, then I'll show you how to build a player prefab for both Steam VR and Oculus now. So for Steam VR, you import the Steam VR asset and go down to prefabs and camera rig. That's the base prefab rig in the Steam VR thing. Drag that into the scene, and on the controller, it's empty except for the Steam VR tracked object script. All you need to do is add the VR Interactor script, and that will automatically add the VR Input script, and it'll automatically set up the base actions all for you in just its initialization. So this is actually already ready to go, and you just need the second controller, add the VR Interactor to that, and that's already set up to go. It's automatically referenced itself as a controller, and it's made a controller anchor offset as a child, all for you, with 0 as its size. You notice that this controller offset, because it's for SteamVR, and there's actually an adjustment between SteamVR and Oculus Native, it's actually put the offset to 50 degrees on the X and a little offset on the X and Y. This is so it matches the same coordinates on Oculus Native. So on Oculus Native, this offset will be set to 0, and that actually matches the same position. So now I've set this up, I'll show you this working by switching this off. So now this is the only one in the scene. Okay, now SteamVR is running, and we'll run this. Yeah. So every time we switch from SteamVR to Oculus, we need to make sure to go to Build Settings, Player Setup, and switch OpenVR to be the top one on SteamVR, and Oculus to be the top one when running Oculus Native. Once OpenVR is at the top, we should be able to load in. So now we're in and we're on SteamVR, the controls are working, and I can tell. And so I'm actually moved a little bit, so I'll move my camera rig to reflect my actual position, which is in the corner of my room. Now I find myself inside the cube, and I can see that it is working, and I can pick up the cubes, and I can pick up this torch. Okay. Now, anytime you do set up your own player prefab, you want to make sure to save this as a new prefab as well, just to solve problems later on. So if you're on Oculus Native, then you'll want to have downloaded the Oculus Native Oculus integration asset, or download it from the website. And you want to start with the local avatar, which is in Oculus Avatar Prefabs Local Avatar. Drag that into the scene, and then you want to find in Oculus VR Prefabs the OVR camera rig, and you just want to drag that to be a child of the local avatar. Like that. Then on the left and right hand, just as before, we're going to add the VR Interactor script, which again is going to autocomplete all of its base stuff. And with that done, we can change over to Oculus. Here, switch off SteamVR. Yeah, the thing that the Oculus local avatar is automatically set up to do. The camera rig is always set to tracking origin eye level by default. Change that to floor level, because this works a lot better with floor level, just for setting up its initial position. Give that a run. And then we see that we're in the thing again, except now we're in Oculus, and it works exactly the same way as it did for SteamVR. And you also notice that the fixed position here is actually the same angle as it was on SteamVR. Okay, so now we've set up the avatars, and we've walked through how they're supposed to be set up. Now let's have a look at the items we find ourselves in this scene. So first we'll look at the most basic item that I could make, which is just a basic cube. You see on its parent object it has a rigid body, and as a child we have just the mesh on its own. It has no additional scripts attached to it. And we also have a separate object which is just the collider. Now every collider object, whether it be a trigger or not, if it's not on the same object as the interactable item script, has a VR item collider on it which references the VR interactable item. So the VR interactable item script, this is the primary script in which all items are based on. So we'll go through all of the variables we see here. The top variable, root object, that's always asking for the root object, as you might expect. In this case, that's the one with the rigid body on it. In most cases, it's the one with the rigid body on it. It also asks for a parent item. This isn't an item that has a parent item, but just as this tooltip says, this is, for example, say the slide of a gun. So on a gun, you'd have sub-objects, and that's what this is referring to. So if this object had an object that you can only interact with while holding the base object, then it would have a parent item in this list. And this is just a list of VR interactable items, of items that would be a child of the root object and share the same space. But in this case, it's just a simple cube, so we don't have that. Now, the hold type, we have a few options, 3 options specifically. The cubes are set to pick up position, this means that the position that the controller was at relative to the object when it was picked up will be the position it's held at. So I can demonstrate that in the scene. It's probably easiest to demonstrate. This cube here, when my hand is here and I press pick up, it is now fixed to that exact position. And if I were to pick it up from, say, this angle, again, it's fixed to whatever my hand was at when I picked it up. So the follow force is the speed at which it will try and track the controller. If I were to set this to, say, something really small, I could test that. And whereas normally it would be 1-to-1, now if I move the controller really fast, you'll see it sort of lags behind. Its follow force is quite a bit slower than the actual speed that my controller is moving at. If it's set to 1, then that's pretty much 1-to-1 motion. And 0.1 there, it'll slightly lag behind. You can use that to simulate something like weight or drag or anything you want. The throw boost, so when you let go of the item, it will give it the velocity of the controller. And then it will multiply that by the throw boost. So set to 1, it will just be 1-to-1 normal throw. But if I set this to, say, 5 and run that, then when I throw this cube, it will actually multiply the controller's velocity by 5, and it'll go way higher. So you can use that for something where, maybe a basketball, you might have a bit more throw on it, right? And it's quite fun to throw something far like that. Okay, so can be held. Now, here we have some of the base. So this is quite interesting. The can be held, if you set this to false, as you might expect, it can no longer be picked up. Now you can use this if you have a VR interactable item that you want to use as a button. So it's something that you can't pick up, but you still want to launch the events. So this is actually still the pickup event, but I've renamed it to clicked event just in the editor. You see that it changes the events, the invokes at the bottom here. So when can be held is false, we have this clicked event, and you can add any action to this. So you can add another script onto this object or something in the same route, and it would call this method anytime the item was clicked. So you can use that to quickly set up a button using a VR interactable item. In this case, it is going to be picked up. Now, toggle to pick up, this is set to false, which means that when you click down to pick it up, as soon as you let go of the key, it will immediately be dropped. So if toggle to pick up is true, then even when you let go of all the controls after you've picked it up, it still won't drop, and you have to actually click the drop button. So for something like a cube that you might be throwing about quickly, it's useful to switch off. But for something like, say, a torch or a gun, it's a lot better to have it stuck to your hand and not have to hold down a button the whole time you're holding it, because you might be holding it for a long time. Break distance. Now, if the follow force is set to 1, break distance probably isn't going to do anything. But if follow force is set to a smaller number, or the can be held is false, then you might want to add break distance, and this will be the distance at which it will just immediately drop the object. So if you set the follow force to be a bit smaller, and you added a break distance, then if you moved your hand really quickly, you might actually drop the item. And likewise, if the can be held is false, then just moving the hand away from the button will be enough to have it dropped. If there's no break force, and this is set to false, and can be held is set to false, then you're actually in a situation where you could click down on a button, and then while holding down the button, walk away from it, and the button would still be considered to be pressed no matter how far away you get from it, which probably isn't an ideal situation. So if you do make a button, you probably want to tick break distance, and 0.1 is fine. That just means that if you click down and then you start to move the controller away while holding the button down, it'll still get dropped as you might expect it to. The interaction distance is the distance from the item's pivot that you can be to actually engage its hover. So 0.1 units is this one, but you can also, so if the controller is 0.1 units from the center, so from the pivot point of the it's actually of the root object, which happens to be the same for this particular one, then it will hover, and you can pick it up when it's hovered. You can also add interaction disabled. This is for if you say it's a button that you don't want to use, or it's an item that you can't pick up anymore, then you can disable interaction, and then it won't even be registered as a hover. It will be basically as if it doesn't exist as far as picking up. Now you can limit accepted actions. I've not actually been able to use this before. So accepted actions, basically if you tick this, then it will only accept these specific items from the controller, from the VR input script. So if you only wanted to be able to pick up this cube via the trigger and not the grip buttons, you could set it like this, and the action button would work, but the pick up drop button would not work. You could also use that maybe if you wanted to have a particular item that you can't drop, then you could add drop to this list, and that action won't be accepted, and you couldn't drop it. The hovers fold out. This is where you can list all of the renderers that you'd like to change when the item is hovered over. So it'll use the current material, whatever material is on the actual mesh at startup ordinarily, and then the hover material will be whatever you set. So by default it will use the unlit texture, but you can specify, like I have done here, a second material, and I've just basically used the default material, except I made it slightly darker because sometimes the unlit texture is a little hard on the eyes. But you can not only set this to a specific material you'd like, you could also change it to just change the shader of the current material. So say this material is the default shader, so it's using the standard shader, but I could say use the same material, but then switch out the shader that it uses instead of the whole material, so it would maintain, say, the texture that you have. Or you could just make a new material that uses everything the same. But this just makes it a little bit easier. So this is set up to material, and I've also got my own specific hover for these cubes. Okay, now the interaction colliders, sometimes distance from the pivot isn't enough. Say for a particularly large item. Like for instance, this table is also an interactable item. And on this item, we have some interaction colliders actually specified. The interaction colliders are the entirety of its body, which are all these separate colliders. So adding something to the interaction colliders just says if the controller is within the bounds of any of these colliders, then it is also within interaction distance. So for this table, this 0.1 pivot is like to the center of the table, pretty much useless because you're almost certainly going to be somewhere else. And I could make this really big, but then it would get confused, and it would anywhere near the table, you would always be hovering over it. So instead, you specify the colliders, and that works really well for larger items. Now, the sounds, there's a few different sounds, and these all just play on the events, fairly self-explanatory. Now, inverse kinematics we'll get to in a different video, doing inverse kinematics. And then, of course, there's some events to every item, pick up and drop events, add a list of those. Okay, so in this main scene, we have these base cubes. We also have this torch. Now, the torch's interactable item is set to fixed type, or fixed position. When it's set to fixed position, it will always be the same position relative to its object. Now when fixed hold type is set to fixed position, this button shows up saying set up hold position, which brings up this little window right here, and you can set up a reference with either SteamVR or Oculus. You can click the set up held position, and it will spawn a reference controller that you can use in order to tell where in reference to the controller it's going to show up, and you can show that for both Oculus and SteamVR, and that position is going to be the same on SteamVR and Oculus due to the offset position of the controller anchor offset. So for this controller it's set up in this position, so it's pretty much looking up that way, and that seems to feel quite nice for this particular torch. So the third type of hold type is referenced on the table, and it's just called spring joint. Basically it does what you might think. It adds a spring joint between the controller and the point at which you grabbed the object. So for this table, the spring joint is wherever you grabbed it. So let's do a quick demonstration of that. So just like I said with the triggers, if my controller is within the bounds of one of those colliders, be it on the leg or on the top, it becomes hovered, and then you can grab it. So if I move back a little bit here and grab this particular corner of the table, you can see that I've grabbed it from this corner and I can lift it up and throw it about if I want. Okay, so that's the 3 different hold types. Now, the only additional bit of functionality is for the flashlight. It has a light on here, and there's a script that I've added called Basic Toggle. And Basic Toggle is just an example of a script that you can add yourself. So let's have a quick look at this script and see how it works. So this is a super basic script, just inherits from mono behavior that I just quickly wrote just to demonstrate what you can do. So you see here, the word action has shown up again, and this is where it comes in useful. So because this uses a method that's called action and takes a VR interactor as a parameter, it now gets called when either you're hovering over or holding the torch. And you see that this name is action, and then if you look at, say, the controller, we can see that the word action is on the trigger key, and it's because it shows up in the added actions. So when I launch the game, and I pick up the torch with the grip key, now you see the torch is on, when I click the trigger key, this one here, on this controller, the flashlight switches off, and switches on, and switches off. So because I'm holding the controller, and I've assigned that little method, it's being called because it's being held. Now, like I said before, it also calls methods for hover items. So for instance, if I'm just hovering over this and I click the trigger key, I've actually set it up so that the order in which it picks up before it calls the action. So you don't have to worry about it accidentally switching on the key when picking up using the trigger key. Now that's actually done by the order in which the scripts appear on the item itself. So for the torch, which is here, on the item, you see that the basic toggle is actually above the VR interactable item script in order. Now if I were to lower this so you see that the VR interactable item script is now below the basic toggle script. That means that the interactable item will process the action command, which picks up the item, and then the basic toggle will process the action command to switch on the light. So if I run that again, now that the basic toggle is actually below, then when I click here, you actually see that when I pick it up, both the torch switches on and it gets picked up. So you need to take into account the order in which the scripts are being executed on the item. So to correctly work, in my opinion correctly work, which is that when you pick it up, even if you're using the action button, it still won't toggle the flashlight. So this is the correct order. Okay, so we're going to put together a brand new interactable item from scratch. So we can start off with our shape. So I'm going to start off with just a normal cube, but this could be any mesh, just a mesh filter and mesh renderer. And this could be your shape that you're trying to build yours around. So the first thing I like to do normally is to make a new empty object and make that the child of that object. And we can name this example cube. And I'm going to add a rigid body to the object. So the rigid body isn't actually necessary. You can go without a rigid body. But if you want it to have physics, then it has to have one. Now, on another empty game object, we're going to add the VR interactable item script. Now, technically, this object could be on the same object as your mesh render and box collider if you wanted to, but I personally normally like to have it on its own separate object. Now, the first thing it's going to ask for is its root object. This can be itself. If, for instance, this script was on this cube and this cube was the parent object, everything could be all on the same object if you wanted to. But in this case, this is our root object right here, the one with the rigid body on it. And then once the root object is assigned, all your options show up, and the options are exactly the same as we've gone through before. The one thing that you should do pretty much right at the beginning, if it's a fixed position, is you set up your held position, if you're using that. Or if you're not using it, then you can just change it to your pickup position or spring position, whichever you'd like to use. And in the hovers down here, you want to specify all the renderers that you'd like to use the hover. So in this case, we just have this one object. Now, the last thing we need to do is make sure that any box colliders that we have, in this case we just have the one box collider, needs to have a VR item collider script attached to it, and that script needs to reference the interactable item that's associated with the object. This script needs to be there, or otherwise the object will completely go crazy when you try and pick it up, because this box collider will not be switched off, and it does need to be switched off when it's held. Okay, so let's have a look at that object working in the scene. So there's our new cube, and we can see that the hover is working because we specified the renderer, and that we can pick it up, no problem. Now, one additional thing I'd like to cover is that if we change it to fixed position, and the position is not 0, 0, and actually is quite far away from its normal position, like for example up here, so then on Oculus it would look like this, so it's quite far away from the center, the pickup position will actually be changed, the pivot position that it's looking for the controller to be 0.1, in this case 0.1 because that's the interaction distance, away from is actually going to be that new position. So we can show that by, on the controller we can add this use hover line on both controllers, and just changing it to an unlit texture for this. We can then go into the scene and actually see that when you're hovering over here it actually doesn't show up because the actual pivot position is actually all the way over here. So if it's held like this, you can see that actually it's looking for this position down here, and if you're further away than 0.1 from it, it won't show up. Sorry, my tracking is waving around. Now, if you're in the object and it's not showing up, you may actually want to add the interaction collider, or it may be correct that it doesn't show up. For instance, if it's quite a long object, like for instance a gun, then you may actually only want to pick it up at the trigger position or at the handle. But if you do want it to show up there, we can add to this the collider. And you could also just make a brand new collider if you wanted to on a new object and make it a trigger and specify that if you wanted a particular area to be covered under it being held. Now if we go in with that setup, even if you're far away from the actual point, as long as you're actually on the inside the cube, it will pick up how you'd expect and act a lot more reliably. For the torch, it's pretty much the exact same setup. You can see, except that I've added the spotlight and this one extra script. And the table, again, pretty much the same setup, except I've separated out all of the colliders into these separate objects and the renderers into separate objects in two little lists, and then specified them in these two drop downs, the hovers and the interaction colliders, and I just changed it to a spring joint, and that is literally it. And that's how it's done. Okay, so that just about wraps up this video. I think I've explained everything in this scene. If you're unsure about something, then you can send me an email at sam@massgames.co.uk. I'll leave a link in the description, or not a link, I'll leave that email in the description so that you can see it. If you have any questions about how this asset works, this is the base asset that is available for free, and I have expanded upon this asset quite a lot in my other assets, the VR weapon interactor being the biggest of them, the Arc teleporter, which just adds the teleport functionality and some smooth locomotion as well. And I have the VR user interfaces asset, which is all about menus and how to make these interactable items, all based on the same classes, all based on the interactable item base class that you can find in this method, just expanded upon to make user interfaces or to make weapons that are complex little internal gadgets, or just a teleporter that takes the VR input script and uses that. So check out the description for all the videos on this channel, just in case I've answered your question in a different video. Okay, thanks for watching.